Live from New York, it's Ask an Engineer.
Hey everybody, and welcome to Ask Engineer. It's me, Lady Ada, the engineer. With me, Mr. Lady Ada on camera control. And this is Ask Engineer. We do 1 hour of news and updates and code and discounts and new products and projects and more. All about what's happening in the maker community. And we're broadcasting live from downtown Manhattan. That's where we have all those manufacturing machines that you saw in the
Yeah.
video. We make stuff. We make stuff and we ship it to you so you can make more stuff. Wow, it's all about making.
Yep,
Let's get right to it because we got a code and we've got all sorts of stuff going on. A lot double new products because
we
last
do.
week we didn't have a show.
All right.
So let's get right into it.
On tonight's show, the code is Proto Under, 10% off the native free store all the way up to 11:59 p.m. Eastern Time. Call
Or
on.
Protounder.
Yeah, whatever way you want to pronounce it's fine.
Yeah.
All the way up to 11:59 p.m. Eastern Time tonight. Use it, and you also have free stuff. We'll talk about that in a bit. Talk a little bit about our live shows, including show and tell. We did not have Desk of Lady 8 over the weekend. We had family visits, so we took off, but we'll be back this Sunday.
Yep.
We'll be doing a highlight from JP's product pick of the week. A little bit of time travel news, a little bit of stuff that's going on, some updates to AdaBox and more. We got some New York City factory footage. We got a bunch of videos because we are catching up. So we've got 4 3D printing videos tonight. We're going to do some Ion MPI analog devices this week, brought to you by DigiKey. A bunch of top secret, a bunch of new products. We're going to answer a bunch of questions. All that and more. We answer your questions. Adafruit.it/discord, discord.gg/Adafruit. That's what we're doing tonight. Big show.
We're here till 9.
Ask an Engineer. Okay, so
Ben.
yeah, so
We're going hacking.
Proto Under is the code. You get free stuff. Lady Ada, what do you get?
You get 10% off when you use the code, and when you order from the Adafruit shop, we always love that because we get to give you some freebies.
Yeah.
Only when you order from adafruit.com. $99 or more, you get this beautiful gold and black PCB coaster made with 2 millimeter thick PCB material, and you get some bumpers to protect your desk, put your hot or cold drinks on it, and look cool and gothy. 149 or more. We're still giving away the KB 2040 and RP 2040 based Pro Micro pinout compatible microcontroller board with all these extras like buttons and LEDs and USB-C. We might be changing this out soon. So if you want one of these for free, order soon, 149 or more.
Yeah.
We still have our free UPS ground shipping in the continental United States, 199 or more dollars in the store, and you get free ground shipping. And finally, we are still doing our Circuit Playground Express giveaway because the chip shortage is over. So we have lots of Circuit Playground Expresses to give away. All-in-one dev board for the SAMD21. It runs code.org CS Discoveries, MicroPython, Arduino, CircuitPython, MakeCode, MicroLisp, all sorts of stuff. It's a lovely little dev board with LEDs and buttons and sensors all built in. So it's a great way to learn how to program without any software or tools.
Okie dokie. Next up, we have a bunch of live shows. We just did our show and tell. That just happened a few moments ago. A little bit of a recap. So on the show and tell, watch it anywhere we stream. Liz showed a really cool Elgato control using CircuitPython. You can use this physical switch to control things. We use this type of light, so I'd like to do that for our setup here, so I don't have to use the software that comes with it. JP had a really cool retro camera. Sun and Moon had an LED fan, and you can check out their journey of making PCBs, flexible PCBs, and ordering stuff from JLC PCB and more. Mark had a flight simulator with physical controls using CircuitPython.
It's on the playground too.
It's on Playground.
Shut off.
Yeah. Do check out our. We'll go over some of the Playground guides when we get to the guide section of our show. And the nanographics had an outstanding, excellent demo of what an electron microscope can do by making it
Inside.
by using a sample to look at an electron microscope mirror, essentially.
Yes, it used
You
a
look at
little
itself.
round. Yeah, it used basically a round mirror, a gazing ball
Yeah.
that would get charged up and then could turn into an electron mirror.
Yeah, and what's neat is like this stuff is actually possible to use and find and make, and Nanographics has some open source hardware they're releasing. So if you've ever been interested in like how particles work or how you can use it to do imaging and more, this was stuff that maybe once in a while you'd see a photo of something from an electron microscope and be like, that's neat, but like how does it work, and is it actually something that you could do? I'm just coming by every week. showing some stuff. So
Yeah.
check out some past show and tells and check out this one. We do show and tell every single week. Next week we'll be doing show and tell. Next week is also AdaBox. So during this time next week we'll have an AdaBox unboxing. Let's stop by. On Sundays we have Desk of Lady Ada. We skipped last week. We had a family member visit, yay! And so we'll be returning this Sunday, and we'll be doing the Great Search and all that. So stay tuned. And then JP's product pick of the week was a week previous, so we're going to play the previous week's highlight.
It is the 3.5-inch TFT capacitive touch feather wing. You can plug nearly any feather into. There it is, just running really quickly through some images there. I am reading one finger, X and Y. Here's 2, 3, 4, 5 fingers. It's really happy to report all that data. We're lucky enough to have a guest on the show, and that is Liz Clark.
RP2040 plugged into the back. And what you see on the front here are 4 buttons. There is a touch button library that works with Display I/O, so you can add these buttons to the screen. And when I press the buttons, you'll see that they register touch. But because this is multi-touch, I can press all 4 buttons at once, and it sees that they've been touched.
And this has been my product pick this week. It is the 3.5-inch TFT Featherwing with capacitive touch.
Check out JP's workshop tomorrow, and then on Friday it's deep dive with Tim. Friday at 5 p.m. Eastern. Let's do some head travel.
Gonna go back in time. Gonna go back in time.
Good news, everybody. If you are an AdaBox subscriber and you've been waiting to do your unboxing, it is next week. So, Wednesday, March 20th, 8 p.m. Eastern Time. Join JP for the return of AdaBox. It is going to be a fun, exciting, interesting.
This AdaBox channel, this AdaBox time.
Yeah.
1 week.
Yeah. So we'll be doing show and tell next week, and then AdaBox unboxing. So that means we're back on track with AdaBox. We really wanted to get AdaBox out the door again. Essentially the thing that kind of spiraled everything out of control. We're at the 4-year anniversary of, the lockdown and stuff like that. So there was COVID and there was a supply chain shortage for all sorts of reasons. And then it took a little while to get parts, pretty much like 2 years. So the second we could launch AdaBox again, we did. Thank you everyone for your patience and support. We very much appreciate it. And some new folks were able to sign up, and we'll open it up for more for the next AdaBox, which we should be shipping over the summer.
Yep, you can sign up now. We have some slots.
We do.
Because some folks didn't renew, so now is a good time because we will fill up.
Yeah.
We actually were full up before, and then we finally got some people managed to sign up. We only had like a 1-week window, but now you have time to sign up for 022.
Yeah. Okay, let's do some Python on hardware. Python on hardware this week in the newsletter. You want to talk about a few things. So we have CircuitPython 9 release candidate.
Yes, finally, enough bugs were squished by Jepler and Dan and Scott and some other contributors that we were able to get out of beta, out of alpha, and into a release candidate. That means we really want more people to use 9.0, find bugs, we will squish them. They're doing an excellent job, and we hope to do an actual release in the next week or two. So everybody will be updated. This is a major release. There's a couple of breaking changes, just documented. You can see the blog post for the changes. I think display.show is one that I think got moved, and also other API changes. SD card mount location needs to exist as a, you just can't make a fake directory on the fly. And then what was the third big one? Boy, I don't remember. There's a couple little details. An MPY format change also, because we merged with upstream MicroPython. So yeah, you're gonna have to re-download your MPY files, but that's a great reason to use Circup or the Bundlefly.
Okay. And then what else did you want to talk about this week?
Let's see. The other thing that I thought was interesting. I don't remember. I remember I told you, but then
Yeah, was it in this?
Yeah, but boy, I don't remember what it was. Shoot.
This will jog your memory as we go through this enormous newsletter.
There's a lot of cool projects. I like this. Oh, well, the pager thing was funny. Oh no, wait, there was something other than the pager thing. What was it though? There was the RC candidate. Can you keep going down? No, no, no. Boy, I don't remember. I feel a little full. I should write it down and send it to you so I remember.
Well, we want to talk about
Oh, this was actually cool. The embedded Swift we thought was quite interesting. So that, I think Apple is like, oh, hey, like MicroPython is kind of cool, but we want people to use Swift. So they've created Swift that can run on
That's
STM and RP2040. So, I don't write Swift, but it's kind of interesting to see a language go back, right? Like not just require like more intense circuitry, but uh going back in time. I don't remember what the other thing, but the pager stuff was, I think, funny.
yeah,
Because when we did pager projects, we did some POC decoding projects using a pager to like get the it's like there's a bipolar signal to like a differential signal that you can parse with like a microcontroller. And so we did a POC decoder that used an existing pager. You'd use the guts of a pager as the antenna receiver, and like people were like totally outraged and like, how dare you decode pager? And I'm just like, it's not encrypted, guys. So if you're
Yeah.
using pager data, it's out there. And like there are people who still use emergency responders, still use the pager network. So I thought it was, it's no different than if you have a radio scanner, you can listen in on radio signals from police, fire department, and emergency. So I thought that was kind of cool to use Python to decode
Yeah.
POCSAG and print it out.
Yeah, that was the one that you want to talk about.
Yeah, I mean, like it'd be people. I remember Kingpin was decoding POCSAG pagers in like '97. So this is a perennial project. Every generation we discover this.
And then the chat, DJ mentioned that Jepler had mentioned this in a weekly meeting. There were about 300 plus unique contributors between 8 and
Oh,
9.
now I remember what it was. We hit the 9,000th issue / pull request. We had PR number 9,000. So now we were over 9,000.
Ooh.
There it is. That's right. It was the pull request 9,000. So it's issue and pull request, but still, it's like that's a number.
That's a big deal.
Also, it's like nice and round.
Yeah, we're almost up to 3,000 learn guides. We have, we've had over
Yeah, this is cool. This is a
4,500
contributor
supported,
fixed
9,000 issues fixed, and
Yeah.
now we're up to 9. So this is the thing.
9,000. It's thematic.
Yeah, one of the cool things about CircuitPython is this is open source. We want the world to have it and use it, and it's it's doing surprising things that we never expected or planned to do, and there's lots of people working on it, and it's something that people run their businesses on. They're able to make hardware and not have to worry about the latest firmware. We generate all the firmware bits and stuff, and there's easy ways to
Can I say a quick thing?
Yeah.
So one thing that's interesting is from a previous INPI, which I had to do the text, the layered module. What I didn't realize is actually they have a MicroPython build for the module for the NRF, and it's they don't release the source code, but it's still very interesting to see more and more companies are using MicroPython as a way to get their eval boards up and running quickly.
Yeah.
A lot of developer investment time.
Yeah, and I think since so many people know Python, I think that's been the change in the past. Maybe there's a lot of efforts, like maybe they'll try Arduino, but I think now Python seems to be where folks to get started really fast are going. Okay, that's Python on Hardware. We do this every single week. You can get this delivered to your inbox. You can get it on GitHub. You can check it out on Adafruit Daily. All those places. Check it out. Okay, let's do some open source hardware news, Lady Ada. On the big board,
Yeah, we have a
we
couple
have almost
projects.
3,000.
Okay, so most of them are updates this week. So for the Itsy Bitsy ESP32, we now have Whippersnapper support. Can you click on the that guide? You can see
Which
all the way to the left. Click on that and then scroll down to Whippersnapper setup. If you want to use Whippersnapper, which is our no-code IoT platform, literally no code's required. You can do everything over a website to upload the firmware to the device, and then you can plug and play I2C sensor, so no soldering, no coding required. You can click on Essentials. Go down. So Essentials up.
Where? Here?
Essentials, yeah.
There.
And then scroll down and click on I2C sensor.
Okay.
So you can plug in, I think in this case we have a temperature sensor you plug in, and then you can use Adafruit IO. Scroll down, scroll down. You can use Adafruit IO to add the sensor device and immediately start plotting it, and you can have, keep going down. You can have like alerts that tell you when the temperature reaches this, above or below a certain temperature. Keeps going. And you can add multiple sensors, and then you can use the feed for different IoT logging, or if you want to like reference it later. And you can also set how often the data is sent, so as quick as every 30 seconds, or as slow as every 15 minutes. We also have like other. Can you like click back and forth, or can I use the mouse?
Between where? Yeah.
Yeah, I'll just use the mouse. So also NeoPixel. So onboard NeoPixel, and you can I think it's really cool. He had little gifs that he made of configuring the color of the LED, and the LED changes color. So check that out. Good work on Tyeth for getting support for this board in Whippersnapper. It's always, it's open source, anyone can do it, but still we like to do it. We also have a new guide from Melissa on setting up the web workflow for the Memento. So the Memento is a camera that uses the ESP32S3, which means you can use Wi-Fi workflow. You don't have to connect the USB cable. You can connect over Wi-Fi to download data, upload data, reprogram it. And in this case, I think she set up a time lapse. And then you can download the images over Wi-Fi from
And also, if you wanted to mount the camera somewhere where you can't get to it.
And then finally, we have a couple updates for the AdaBox 021, just adding more projects and links. Just don't forget that unboxing is next week.
Okay. And then, as we mentioned before, you can go to Playgrounds. It's linked at the top.
You can refresh. There's a new one.
Oh, yeah? Already?
Yeah. The flight sim controller.
All right. Custom flight sim controllers with CircuitPython and Mobi Flight. And then check out all the rest of the guides and more in Playgrounds. You could post up there. Share your projects with folks. And you can see if your project was on the show and tell, or if we've, we love all these. But
we love all of them.
We'll give you a little badge.
Sometimes we love some a little bit more.
All right. Here is some factory footage. And that's factory footage of the week. This week, we're going to do some 3D printing. We have 4 videos because we're catching up. So we're going to play these back to back to back to back. It's going to be like about 4 minutes altogether. So we'll see you on the other side.
This is Memento, Adafruit's DIY programmable camera dev board. With Memento, you can take photos using the fancy camera software with CircuitPython. You can take photos and save them as JPEGs or animated GIFs. You can even apply image filters like this Game Boy-like effect. You can use the built-in buttons to change settings like the photo resolution and switch between different image filters. The Memento features the ESP32S3 Wi-Fi chip from Espressif. It's a dual-core processor running at 240 MHz with 8 MB of flash and 2 MB of PS RAM capable of Wi-Fi and Bluetooth LE. On the front, it's got a 5 megapixel camera sensor with built-in autofocus. It's got a USB-C port for programming and built-in LiPo battery charging. The built-in color TFT display has a resolution of 320 by 240 at 1.5 inches. There's also 6 user buttons, a microphone, a speaker buzzer, and an accelerometer. On the side, there's 2 3-pin JST ports and a STEMMA QT port, along with a micro SD card slot. The LED ring plate is an add-on for Memento. It features 8 NeoPixel LEDs for adding unique lighting effects to your photos. You can cycle between colors in the LED color mode using the direction buttons. You can also adjust the brightness of the LEDs by going into the LED level mode. The Memento features CircuitPython support for fast development. With the Pi camera library, it's easy to make custom camera projects. The fancy camera example code gives you a point-and-shoot experience where you can cycle between modes, image filters, and NeoPixel LED colors. The Adafruit Learn Guide features even more example code, so you have tons of projects to get you started. Our 3D printed enclosure features an LED ring diffuser. The 2 halves can be printed without any supports and snap fit together without any fasteners. It features access to all of the onboard components and the expansion ports. It also features a spot for a threaded tripod screw insert. We've been enjoying the time-lapse feature that's a part of the CircuitPython fancy camera software. It lets you adjust intervals and automatically locks exposure so you can capture smooth time lapses. For longer time lapses, you have the option to adjust the power to save battery life by dimming the TFT display. That's just a few things you can do with Memento. There's tons of other projects you can make, so be sure to check out the Adafruit Learning System. We hope this inspires you to check out the Adafruit Memento and start making camera and vision projects. You can build an interactive robot that tracks your face using Memento, Adafruit's DIY camera dev board. This project uses code based on the camera web server example from Espressive. The code was modified by Brent Rebel to be compatible with the Adafruit Memento. This isolates the face detection code and draws a bounding box around a face on the camera's built-in display. A servo moves the robot's head and actually follows your face. When the robot detects a face, a NeoPixel ring lights up, making this feel like an interactive companion robot. The Adafruit Memento is an open source camera that features the powerful ESP32S3 Wi-Fi chip. It's got a 5 megapixel camera sensor with autofocus and built-in JPEG encoding. On the back, it's got a TFT display, buttons, accelerometer, speaker buzzer, and microphone. It's packed with awesome goodies and features. The Memento features the TinyUF2 bootloader so you can easily install new firmware. The code is available as a file that can be uploaded using Adafruit's Web Serial ESP tool. For advanced users who want to tweak this project or expand it, you can modify and compile the code using Platform.io. Be sure to check out the guide on the Adafruit Learning System for a code walkthrough and CAD files. We think this project is great for intermediate and seasoned makers who are looking to make advanced camera projects. You can pick up the parts to build your own face tracking robot from the Adafruit shop. The CAD files are free to download, links are in the description. The NeoPixel ring press fits in front of the robot while the servo is secured to a 3D printed bracket. The Memento is secured to the same bracket with fasteners and everything plugs into the dev board's expansion ports. The main bracket is mounted to one half of the robot and then joined together. A servo horn is sandwiched in between 3D printed plates that have press-fitted neodymium magnets so you can easily prop it up on your shoulder. We hope this inspires you to check out the Memento for building your next robot or computer vision project.
it's a bunch of 3D printing. Okay, don't forget the code is Proto Under. We're gonna roll right into Ion MPI.
On MPI.
Ion MPI brought to you by DigiKey and Adafruit. This week it's analog devices. Lady Ada, what is the new product introduction of the week this week?
Okay, this week we're going back to ADI. We kind of did a couple other brands, but now we're back to classic. So ADI, this week's I on MPI is, I know it's a blank chip. It's their I coupler I squared C galvanic isolation chip, which is the ADUM. So I said LT. They also own linear, but ADUM 1252 and the 1253. So these are bidirectional and unidirectional I2C isolators. They are specifically designed for electrically isolating the I2C controller and peripheral. There's two versions. One has a bidirectional SCL pin. It's a little bit more expensive, but supports clock stretching and multi-controller mode. And the less expensive, I think the 53, is unidirectional. There's one controller, one peripheral, and there's no clock stretching. Okay, so isolation, when do you need it? Well, there's like three basic usage, although like one of them is two usages. So hazardous voltages or noise, so industrial or robotic usage, where there's a lot of high voltages, or there's a lot of electrical noise that you're dealing with and you want to isolate your motor power supply and ground totally from your sensor power supply and ground. You might want galvanic isolation. Secondly, medical devices. So a lot of medical devices, they're in literally messy situations. There's a lot of liquids and fluids, and they're getting kicked over, and they're you don't want to have anything accidentally connect a power supply to the sensor that connects to somebody's EKG. They often have high sensitivity requirements. Again, you don't want a lot of noise. And then also regulations, especially for power equipment. You might have to have, there might be a legal requirement for you to keep grounds and power supplies separate. This is where you want truly electrical separation, not just like a little ferrite bead to kind of clean up the power supplies, but there's literally no electrical connection between the ground and power on either side. Just an example, especially like, you're doing a robot or a medical device, you have an ADC that you really want a nice quiet power supply. You have an analog ground and analog power, and you want to be separated from your microcontroller, microcomputer that's running at 3.3 volt power and logic and has an earth ground and maybe a messier power supply. This is where the ADUM 1252 and 53 do an excellent job. So what's interesting is that the ADUM series uses a galvanic isolation that's not an optocoupler. Speaking of the next one, this is kind of what a lot of people think of when they think of MIDI has isolation. There is a package, and they're usually kind of chunky packages. There's literally a light and a photodetector, and then signal is sent, usually digital signal. There's maybe some cleanup that helps transform the digital signal into the right LED output, and then the receiver is a phototransistor, and maybe there's like a Schmidt trigger or something to give you some hysteresis control. And the whole thing is potted, and so this gives you full electrical isolation because the light doesn't pass current, and there is no electrical connection between the input and output. The problem is that often these, well, first off, they're not bidirectional. Obviously, they're unidirectional. You'd have to have like a separate optocoupler for the other direction. You'd have to have support circuitry to switch directions and all that good stuff. Second, they tend to use a high current because you need to have the LED turn on nice and fast. And sometimes the photodetectors aren't very fast either. And so you'd have to get a special version if you're going into like the high kilohertz, megahertz rate. So Analog Devices has the iCoupler series. And the way this works is it uses, instead of an opto isolation, it uses an electrical isolation using a transformer. So if you look at, and this would be great under the electron microscope, nanographs, by the way, if you decap the chip, there's literally two halves with little coils that are created by using a standard wafer technique, but then adding a polyamide insulation layer and then another coil on top. So this is like kind of half circuitry, half post circuitry, manufacturing technique, but they've been doing this for 2 decades. So they've gotten really good at it. And you can see there's two kinds of coils. So there's some ADUM chips that do power, and you can see in the middle image there's like two bigger coils and then four smaller coils. So those that that's a chip that would do both power and signal transmission. But the chips we're talking about don't do power transmission, so you do have to supply the power and ground on either side. Although I'll say with our USB isolator that we sell in the Adafruit shop, we have we have two chips, and one does data and one does power, and the power one does this electrical isolation. It's like a mini transformer and DC-DC converter to give you 5 volts on either side of the for output from the 5 volts input, but again, fully isolated. The only thing is you're like, wait a minute, transformers, I know transformers, they don't pass DC, they only pass AC. That's why they're used for AC transformation from, whatever, a couple thousand kilovolts down to your home 120 or 240, and then from your 120 or 240 down to 12 volt AC, although we tend not to use transformer-based power supplies as much these days. They are used in some situations, but you need to use AC, you can't use DC. And so what you need to do is convert that DC, it's not DC, it's digital signal, but it has a DC component. It's not true AC. Convert that to AC and then decode it. And so if we look here again, this is mostly what the circuitry is doing, is actually handling that encoding and decoding bidirectionally. Okay. There's also some extra circuitry in there that I thought was kind of nice. They added in. They added a hot swap controller. So if if you're doing this safety isolation, you probably also want to make sure that you don't end up with a stuck I2C bus, which absolutely can happen if you like hot plug in a device, or if there's a wire that gets jiggled or whatever. You have your, something come in at the middle of an SCL pulse. You can get very confused because you really want it. It wants to see 8 SCL pulses before it, knows what to do next. And so on one side, there is a pre-charge and a glitch filter. So it will determine when you're actually at a stop condition on the I2C bus, and then it will connect the two sides together. So you can also use it as a hot swap controller, which is kind of nice. Like it's like a two-for. You don't need a second hot swap controller as well. There's also an under voltage lockout. So if I think you can use either side as a level shifting I2C converter, 1.8 to 5.5 volts. So either side can be 1.8 to 5 volts, and you can shift up or down. In addition, if you go below 1.8 volts, there's a lockout, so you won't accidentally have them, have an under voltage affect the signal on the opposite side of the galvanic isolator. While this chip is I2C, there are different isolators available from, USB, LVDS, amplifiers, RS-232, SPI. So, or ADC or CAN even. So, this is specifically for I2C. It's really only designed for I2C. Please don't try to push it into CAN bus or something. But if you do want isolated CAN, check out the iCoupler series. They've kind of, cooked this technology into every kind of isolation transformer you could possibly need.
Available in Digi.
Yep, both versions. So again, one is a little bit, the 1253 is a little bit less expensive, unidirectional. SCL pin 1252 is a little bit more expensive, but has bidirectional SCL for when you have multi-controller or clock stretching.
All right, we have a really good video we're going to use.
That's right.
Hi, Dave.
Hello, Mark.
We have been building and improving our digital isolators for years, and I still get questions from people about whether our insulation is as robust as an optocoupler. It's like gossip, it just keeps coming around.
Yeah, it really is frustrating after all the materials research we've been doing. It'd be really great if we had some dynamic way of showing how robust the insulation really is.
I think I have just the thing in the lab. We can do a side-by-side transient isolation comparison between optocouplers and digital isolators. Come on, let's go do this.
Okay.
So what we have here is one of the most powerful surge testers on the market. It's up to 24 kV, and it will deliver up to 40 joules of power on every pulse. That is enough to ruin your whole day. And we also have a high-speed camera to catch any failures.
Is this the machine that does the 1.2 by 50 microsecond pulse that the agencies use?
It's exactly the same. And VDE requires a 10 kV pulse as a proof of reinforced insulation. So we're going to start with a 10 kV pulse. go.
Yeah, but we all know that the optocoupler's going to pass this test.
Yeah, but fair's fair, and we really need to test both of them.
All right, just make it quick.
Let's put in the digital isolator.
Well, we know that both optocouplers and digital isolators will pass this test. That's why we get the questions. Optocouplers claim to be much better than the standard, while people worry that digital isolators are just barely passing.
Well, it wasn't a very exciting test, I'll grant you that. But what do you say we turn this machine all the way up and really test the limits of these technologies?
All the way?
Sure, 24 kV. What'd I tell you? And here's the optocoupler. Okay, 24 kV, here we go. Woohoo! Now that was an impressive failure. That blew that optocoupler clean in half. Let's look at that again in slow motion. I would say that result is a pretty clear rebuttal of the gossip. Digital isolators are as capable as optocouplers. They have matched and even surpassed them in critical safety parameters like transient withstand. Well, my work here is done. Make sure that you lock the lab on the way out and sort of clean this up. The lab manager likes it tidy in here. Wait a minute.
On NPI.
All right, we're going to roll right into new products. Before we do, don't forget the code is Proto Under, and here we go. Just introduce yourself.
Oh, new. I almost forgot.
Yeah.
New.
All right, first up.
Been a busy day. Okay, so we've got an update for this M5 stack, like cool little watch thing. Biggest thing is the screen's been updated. I think it was like 128 by 80, and now it's like 160 by 128 or something. It's a nicer resolution screen. Oh boy, on the back is it's 135 by 240 instead of a 0.96 inch display. It's got the ESP32 Pico, which we love inside. I think the battery's a little bit bigger, and I think a couple of the sensors got updated as well. But this is the most adorable little dev board. So if you want all-in-one ESP32 with a display, buttons, and a case and a strap, we have these back in stock.
Next up.
Next up, we also finally have back in stock the Memento case kit. So if you have a Memento camera and you want the beautiful Paint Your Dragon designed case with the front plate that has an RGBW LED ring and the back plate to protect the buttons and the hardware and a little adapter JST to power the LEDs and the sticker to mount the battery inside. Check out this case kit. We'll be making a lot more of them soon as well, but it's a great addition to your Memento. Next up, we had a request for some thicker solder wire. This is not lead free, it's leaded solder. I know this isn't 60-40, but I call it 60-40 because it's like 63-37. It's very, very close. It's actually hard to get true 60-40, but this is close enough, I think. And it acts the same. I love this series of solder. I've been using it plenty. Just remember, it's not Rojas, and it never will be. It has lead in it. So use it where you definitely need lead. We also have lead-free solder, of course. And it has rosin flux in it. So great for kits. This is a thicker wire, so good for through-hole soldering. Will make it a lot faster. Speaking of through-hole soldering, what you don't need that solder for is this board. It's the Feather ESP32 V2, which we released a year ago. It's got the new Pico modules, so it's got 8 megabytes of flash and 2 megabytes of PS RAM. So it's a really nice upgrade to our Huzzah Feather. With a smaller module, we also had space for a NeoPixel, for a STEM QT port, and a second regulator. Yeah, second regulator. Still has a USB serial converter and battery charging and all that stuff. And now if you want to use it without soldering any pins, the pins come pre-soldered on it. So you just, as you see here, plug and play. It's $1 more, but could save you some time and effort if you want to get right to it.
Next up.
Okay, next up, we have a series of boards that are new Pico bells. So we're going to talk about all of them together and then I'll show them off. So this is the terminal bell. So this has terminal blocks on the side. There's big green things, and those allow you to connect, I think, 18 to 26 gauge wire. But look at the product documentation in case I don't have the number correct. Using any small flathead screwdriver, you can open up the terminal blocks and plug the pins in. And what you're supposed to do with this version is you can solder in socket headers, or you can solder the Pico directly in, or underneath, however you want, and you get those terminal blocks, as well as some mounting holes. We also have a version that'll be in stock tomorrow with the sockets already soldered in. So it's a little more expensive. So why would you want one or the other? Well, with the socket soldered in version, it's ready to go. You just plug in your Pico directly. So we can go to the overhead and I'll show this off. So this is the version without the sockets plugged in. And this is my prototype, so it's green, but you can imagine it's very similar. Don't forget to look at the bottom to see which way is the USB port. The USB or look at the pins. So this is pin 0 and 1. So this is where the USB goes. So with this version, you can just plug right in, ready to go. If you have your Pico H or the Pico WH especially, it's going to be really easy because it's just ready to go. And then you can connect to the terminal blocks. You get a stomach QT port and a reset button. With this version, you do not get the header soldered in, but it means you can do funky stuff. Like you can use stacking headers if you want this to connect through to something on the underneath. You can't do that with this one because it's already soldered in. So this is a little bit more advanced, but more flexible. Another thing is if you soldered the pins on your Pico, like upside down, as it were, you could plug it in from the bottom and solder it to the top for like a very slim, setup. This is a Pico bell, but the same idea. Or if you wanted to solder it directly in, you could have another, again, a very slim, hold on, let me line this up, a very slim setup, solder it directly into the pads here, and then it's not sticking up at all. So, more configurable, more advanced, but not as plug and play. So those are the two versions of the terminal bell.
Okay.
And you have, just to show the terminals, there's a terminal block for each pin. So there's going to be lots of ground pins, and then, one for each GPIO. And then on the bottom, you can see the labeling for what each pin does. Just look on the bottom. And then I also have like 4 little break apart feet mounting, or you can remove them if you want to keep it slim.
All right. And then stars of the show tonight, besides you, Lady, our team, our customers, and everybody who makes this thing is
Dun, dun, dun. It's the Proto Underplate, which is why the code is Proto Under. So this is kind of an inversion of our Pico Bell Proto. Again, you can plug in your Pico into it. And what's nice is that we use double row headers. So you can see there's a row of headers on the side you can plug wires into very easily. So you can connect it to a breadboard, or you can, plug LEDs or buttons directly in as you like. You get a prototyping area in the middle, a reset button and a stomach QT port, and all the pins are nicely labeled, plus mounting pads. Another thing that's nice is, go to the overhead real fast. We left the holes on the bottom. And so what this means is that it's really hard to see, but these are actually like kind of hollow connected through. So if you have, again, stacking headers, if you want, you can put stacking headers through here. Imagine that this is 20 pins long and you have 2 of these. You can plug in your Pico and then the pins come out the bottom, so you can then plug something else in. So you can have it like stack through, and that's why these are super slim style. And then you have nice labeling. And then of course this works with the, whoops, hold on, there's the Pico here. And then the USB port. Yeah, you can plug the Pico or the Pico W. If you have the Pico H, of course, you're going to be most happy because there's no soldering required. And it's like a nice slim contraption. You can use the prototyping area, or like I said, you can plug in wires into these pins here. I should have brought a wire with me, but you can imagine plug wires in here to connect to any of these pads that are nicely labeled, and they all echo each of the GPIO on the Pico, all 40 of them.
all right. And then we have
and then we have coming soon. It's going to be in a little bit later, maybe later this week, the doubler version. So I took that board and then I did the clone tool and I put 2 side by side. So now you can have your Pico. You see on the right, there's like a Pico, and on the left you have like a DVI Pico bell. So if you want to connect a Pico with a Pico bell or other circuitry together, and you don't want to stack them, you want to have them side by side, the doubler will do that. And another nice thing about the doubler is if you click here, so you have the STEMMA-QT connector for plug and play sensors, OLEDs, whatever, and the reset button. But it doesn't make sense to have two reset buttons and two STEMMA-QT ports because they're chainable. So on the right side or the other side, we have a battery connector for your like standard lithium ion or lithium polymer battery with battery charging circuitry and the auto switch. So if you plug in USB, it'll charge the battery. And when you change over, when you unplug the USB or you depower it, it switches to the battery to run. And then that will go into the VSys pin that will power the buck converter on the Pico or Pico W. So it's like an auto switching battery backup. And then on the bottom of the board, if you have alkaline batteries you want to use, you can cut to disable the charger. And that way you can use this with 3 AAA or AA batteries. And you can, it has a little bit less prototyping area, but I think it's worth it. And then since you're on battery power, you don't want to unplug and replug the USB constantly. There's an enable switch. So the enable switch will let you turn off the buck converter on the Pico W to save power. So it'll be really good for wireless projects as well. You can use it without the second port being used if you just want like, oh, I want like, this, battery charging and on-off switch and reset button and STEMMA-QT. But this way you get a little bit of everything, kind of like a nice sprinkle of different hardware accessories that'll make your Pico much, much better.
Good products.
Yeah, new.
Yeah. You've featherified the Pico platform.
I'm featherifying it. Well, because I'm doing more Pico bells, and I was like, oh my god, I really use, especially with wireless projects, you want a battery power.
Okay, we have some questions lined up, but we're going to roll right in. Top secret. There are any questions. We're going to try to get in here on 9 on that. We can actually. Here we go. Here we go.
Get on the ball. Hurry up.
Top secret. Speed round. What are these?
Okay, this is like a little breakout board that will let you just connect STEMMA-QT, and it has little pull-up resistors and LED. And then I made 2 Trinkies. So I have a lot of SAMD21 E18s. I gotta get rid of these. And I was like, oh, I should get back to the Trinkies because we were making like a Trinkie a week. So this one has a SAMD21 with a reset button, NeoPixel, and SHT45, which is like a really nice precision temperature humidity sensor. Now for the final version, I actually added a little cutout to isolate the SHT45 because there's a little bit of self-heating going on. I also made a version with the SHT41. This is somebody requested this. They wanted a little fan simulator for like a computer to like simulate a PC fan. So I was like, oh yeah, the little like 555 timer with a little potentiometer could be useful. So there's a little switch to switch the capacitor, so you can do 0-ish to 250 hertz or to 25 kilohertz. You can do it for audio on the right, or you flip it, you can do it for fans, which are like about 100 hertz. And then this is a USB host BFF. So using the Max 3421E and an on-the-go micro B connector, you'll need like an on-the-go adapter, but you can add USB host. We're doing a lot more USB host stuff with the Max 3421. We've got great Arduino support, and more CircuitPython support is hopefully coming soon. So this could be, you can make really tiny little USB host interface. And then finally, the Great Search 2 weeks ago, we were looking, because we were talking about the SHT45, and I was like, well, what other humidity sensors out there? We found this really cool, ultra precise, 0.5% accurate, relative humidity sensor. So a little breakout board with, again, a little cutout to give it some thermal isolation.
And that is this week's top secret. Okay, rolling right into questions. We're going to get to all of them. There's a bunch. While this is loading up here, we made a recommendation to check out the Root robot, and someone got it, and the person liked it. So
Yay.
yeah, we thought that would be
Okay.
a good one. Okay, first up, I could probably do this one. Someone got one of the CarPlay LCDs. It doesn't work anymore. Are all TFT panels with 40 pins and a 4-pin touchscreen, are all the pinouts the same?
They probably are. It's probably like the standard 4.3-inch TFT display. And so if you look in the shop, there's 2. There's the RGB 666 and the RGB 888. It's probably the RGB 888. So you can use it with our DPI Keepa, which is like a board that lets you use Raspberry Pi. And we also have a TFP401 board that'll do HDMI to those displays if it's the same, which
Okay, this
it's a
one's
rectangular.
pretty long one. You might want to read this over. They would like to connect 1632 of the quick Neo Slider linear encoders to the macropad. Can they use the Adafruit PCA 9548 Expert C multiplexer to do this?
Basically, they're like, can you use 2 multiplexers? Yes, you can. Just your code's going to be like a little hairy because you're going to have to make 2 multiplexer instantiators, and then within each 2, remember to do the 8 Neo sliders on each one. There's no reason it won't work. Just keep track of which is which because it's a
Yeah,
lot.
They want to support
Yeah, you can do
two
it.
channels. Plan to order these and try. Just want to ask first. Yeah, it looks like you can.
You can do it, but it's just like, again, just do 1 multiplexer, add the 8, and then add a second multiplexer and add 1, and then add the 8. So go slow.
Cool. Okay, question about the LM66200 ideal do diodes. Would the expectable usage be with solar panels, having 2 identical solar panels, each on separate VIN pins, and it would switch to the higher voltage and in theory offer 2 angles to get more daylight? Example layout would be sunrise and sunset.
Yes, as long as the voltage out of the panel is within the LM66200 max voltage, which I believe is 5 volts. That's not a 16-volt ideal diode. So that's the only thing you got to watch out for. Don't give it 7 volts if it's an open circuit voltage of like 7.
Okay. Is there a breakup board or some way of testing isolation rather than big lab equipment?
I mean, if you're really testing it, there's no better way than having lab equipment. I wouldn't recommend at home taking like mains voltage and just like plugging it into your isolation circuit. People who make these circuits for medical devices or power or robotics, they will use a testing lab.
Okay. For the Memento camera, why did you do the 3-wire bridge to the front back? Could have instead done a pogo pins, or is a tall header pin bridge?
Oh, I didn't want anything to stick out and get knocked off of the Memento, and so this was actually of all the way. I was thinking like, oh, I could use the standoffs as, but then I was like, let's not try to be clever. I think cleverness is it's clever, but then you regret it later. I wanted to go simple.
Okay.
So this is simple.
ST Micro, and that's a 64-bit microcontroller, as we're named the STM32MB25. What are your thoughts on a 64-bit micros and CircuitPython will eventually run on it? Niche overkill inevitable.
I mean, I think it's interesting. Eventually, yes, there will be 64-bit microcontrollers. I don't think we need to address that much RAM yet. So, I guess it would be for computation. I mean, I think that, if it says MP, it makes me think that's maybe a crossover processor. So it's a microcontroller, but it probably is also fast enough to compete with their F7, H7 line, maybe one Linux even.
And then how's our Switch going? The KeyCAD going? We're getting there. We're just
it's a little around.
Yeah, we're going to be publishing as our journey gets started. When we can do a series of guides, we'll be doing that, so you'll be able to.
After 2026, so
we got some time. I think a meteor is going to hit in 2026 anyway.
Oh yeah,
yeah.
Well,
apparently.
there you go.
Okay, and I think those are all the questions.
Okay, great. We finished exactly on time.
So I want to know, I'll answer this one. Have we heard from Radio Shack lately? No. They were...
ever since they're like weird...
So what happened? Yeah, the brand got acquired and then was like a holding company. And then we interviewed one of the new owners and now it looks like it went to someone else. And
did he sell it again?
I think so.
Oh, yeah.
We don't really keep track of it. I measure time by who's the new CEO of Radio Shack.
You should interview the new CEO. That's
a
standard issue.
I'll say this. Unfortunately, though, my days of journalism are coming to an end. We interview the CEO of Radio Shack. I interviewed one back when I was at Make.
Yeah.
But unfortunately now when you interview someone, they think you're like, must be a paid promotion, or this has something
or like you agree with everything.
This has something to do with crypto, or why did you give that person a platform? I just wanted to know what Radio Shack's doing, and our community wants to know what Radio Shack's doing. And like we put all our editorial disclosures, like we don't get any money from anyone for doing editorial.
I didn't even get batteries.
Yeah. And I get it because the world is kind of broken and everyone assumes the worst. But every time I've interviewed someone recently or done something, you're like, oh, this is an industry plant. It's like, No, we're just interested in what Radio Shack's doing because it's a brand that people knew, and that's where a lot of people used to get
To
electronics.
be honest,
It has nothing to do
most
with.
people should say no to getting interviewed from us because usually after you interview somebody, then like something very bad happens.
Yeah, I mean, so
Like statistically.
actually we're going to bounce, but kind of a funny thing. So a million years ago, when Tech Shop was going under, someone bought it up, and it was like there was all sorts of controversy surrounding. And I interviewed this person named Dan Rager, and I said, okay, like what experience do you have like running a company? Are you gonna like run Tech Shop into the ground? He's like, I had interest in my wind farm from Mike Pompeo. And I'm like, the Mike Pompeo? And that was like Secretary of State. And now there's, talks this might be a choice for a vice president. So I'm like, I was Googling like Mike Pompeo, and I'm just like, I wonder if my article is going to come up. Sure enough. So now someone's going to accuse me of, being in politics because I mentioned in an interview from someone's words that they worked with a guy. So anyways, that's how it goes. So anyways, probably
No, it's 9 o'clock.
I don't know what's going on with
We gotta go.
Okay, we'll see everybody later.
Bye,
Thank
everybody.
you so much. Don't forget the code is proto under.
The code is the Mike Pompeo.
No.
No, it's
It's been an
Proto
Adafruit production. Thank you so much, everybody. We'll see you next week. Here's
Bye, everybody. Have a great week.